People often ask whether this is like an existential issue. Can humanity survive this? I'm not too worried about humanity. I'm far more worried about society. What's amazing is that you don't really expect a few lines of code to really reproduce the whole world. But when you test them, when you evaluate these models, in case after case after case, they actually tell you something real about the real world.
We're here in front of the building you might best know as the coffee shop from Seinfeld. In reality, it's home to some of NASA's top scientists who are running powerful computer models to project the future of Earth's climate. So you were here way before Seinfeld?
We were here way before Seinfeld. It is an odd thing because, every day there are people taking their photographs in front of our building without having the faintest clue what is actually going on in our building. My name is Gavin Schmidt. I'm the director of the Goddard Institute for Space Studies. We are an offshoot of NASA, particularly the Greenbelt Goddard Space Flight Center, and we work mainly on understanding climate observations. So one of our major pieces of work is the development and the evaluation and the application of climate models. So these are large global simulations of all the things that we think of as being important in the climate system, where we have a numerical laboratory where we can poke it and we can prod it and we can see how it would react to a big volcano or increases in greenhouse gases or to the ice age cycles.
In essence, it's kind of a powerful simulation of the planetary system, correct? And what is a model? What goes into a model?
So a model is just computer code. Our model is around 500 to 700,000 lines of active code. Each of those segments are broken up into processes. So what we do is we look at the real world and where we see important physics that's going on that's associated with the climate, how clouds form, how clouds produce rain, how winds change the ocean currents, and we take all of those different pieces and we just kind of glue them together.
Right, 500,000 to 700,000, that's a lot of computer code.
It's 500,000 lines because we've been working on it for about 30 to 40 years, and we've been building from something that was relatively simple, but we've been making it more complex as computer technology has advanced. We have a supercomputer which is the size of a large warehouse, and that allows us to do many hundreds and thousands of years of simulations. So you put in more physics that you understand, or you put in something more complicated, and the skill of the model increases.
Can we use the models to convince people that climate change is real?
There's quite a lot of people who are so wedded to the idea that nothing is going to change that it really doesn't matter what you tell them or what you show them, they're not going to change their minds. Do I think that we could do a better job demonstrating to people that these models are skillful? Of course.
That's the most important thing. The science is off. We just had a snowstorm 2 weeks ago in New York. They told us New York City was going to get blown out. We had to give up our freedom and sit in our house, no cars on the road. Well, guess what? The models were wrong. So they got the models wrong on the science 24 hours before. How about those models 10, 20 years from now?
Let me step in.
One of the refrains that I'm sure you are beyond tired of hearing is, well, we can't predict what the weather is going to look like a week from now. How can we trust a model?
This is just a very bizarre framing, right? Models are just tools. You don't believe them or trust them. They're not people who have credibility. They are tools that you can test. Right, and so there are some things where the models have skill, and there are some things where they don't. Right, so for instance, if I tried to predict how many tornadoes they're going to be using one of these global scale models, I'm going to fail miserably because they don't have the physics or the small scale aspects that would allow them to reproduce tornadoes or really understand anything about tornadoes. However, there are lots of things that they do well. And global mean temperature change is one of those things that they do well. The patterns of rainfall change, they do well. The changes in the dynamics, the changes in sea level, all of those things they do well. And we can evaluate that, we can test that by comparing the results of the model in cases where we've had big changes in the past and we have data to say what happened. This is the output from the model, which is very, very complex, many, many variables, all the different levels in the atmosphere, and you're trying to visualize part of it. So this is a simulation of particles in the atmosphere, and each of the different colors is a different kind of particle. Just north of Madagascar, there'll be a small volcano that goes off, and that's putting sulfur dioxide sulfate particles into the atmosphere.
And what are the models indicating is going to happen in the future right now as it pertains to climate change?
So the dominant forcing now is the increase in greenhouse gases, particularly carbon dioxide. And so the models that we use and the models that other centers are putting together around the world all indicate that that is going to lead to a warmer planet by 2, 3, 4 degrees, 5 degrees perhaps by the end of the century. And the scenarios that we look at, right, we look at ones where we don't make any decisions and like we just keep on, burning fossil fuel. And then there's other scenarios where, we make a very aggressive effort to reduce emissions. We, the economics assumes that there's a carbon price, and it assumes that technology has progressed so that we can, replace carbon fuels with renewables or nuclear or whatever. And they give you very different outcomes. And in terms of the disruption that is going to occur, the key things that are going to impact people are really the rise in sea level and changing patterns of rainfall. So more rainfall in the higher latitudes, but in the already arid areas we're going to see less rainfall. So places that are already water stressed are going to be even more water stressed. Those are the places where we as a society really have the most vulnerability.
Does looking at a world like that with that model concern you personally?
The worst case scenarios for where we're going to end up are if we continue to burn all the fossil fuels as if there is no tomorrow. And that's the key thing. We have choices. We're making decisions every day that are pushing us in one direction or another. But I don't think it's like an extinction level event for humanity as a whole. But what kind of society we would have after 100 years of this, that's a very open question.